Hello, welcome to this video tutorial on reactions of acids. In this video, what we're going to do is have a look at how acids react with metals, metal oxides, metal hydroxides and metal carbonates. And then from that, can we write some word equations and some balanced symbol equations as well. So it's purely looking at writing equations on this one. I'll do a separate tutorial on pH neutralisation and making soluble salts as well. Okay, so to start us off, what actually is an acid? It's a word lots of people have heard of, but might not actually know what it is. So to begin with, I'm going to give you 3 acids and their chemical formulae. So the 3 most common acids that you will come across are hydrochloric acid, HCl, sulfuric acid, H2SO4, and nitric acid, HNO3. And now if you look at the chemical formula of each of these, you will see that they've all got something in common, and that is that they've all got H at the start of their chemical formula. So acids have hydrogen in them, and more specifically they have hydrogen ions, so H+. So all acids contain H+ ions, and acids when they're dissolved in water will release H+ ions in solution. So here I've written an equation for what happens when we dissolve hydrochloric acid in water. So we've got HCl put into solution, releases hydrogen plus ions and chloride minus ions, and I've done it in diagrams here as well. So we start with the compound combined together, and then the ions dissociate, which is a good word, it means split up, dissociate in solution to give you free H+ ions and Cl- ions. And it's this part here, these free H+ ions, that make something an acid. Now, one thing you probably will have heard of to do with acids is their pH. So here we've got very rough pH scale in terms of the colours that would be shown if you used universal indicator. And we know that pH 7 is neutral, so that's not acidic. And the acids are low pH and the alkalis are high pH. So these are your strong acids, which are kind of pH 1 and 2, and these ones are your weak acids as we get closer to the middle, closer to neutral. Okay, then equally on this side we've got weak alkalis going up to strong alkalis. So your strong acids and alkalis are at the extreme ends of the pH scale. Now I don't want to go too deep into what strong acid and weak acid means at this point, because we can do that in another tutorial, but very briefly, strong and weak is to do with how well the ions dissociate. So a strong acid like hydrochloric acid or sulfuric acid, when it's dissolved in water, every single one of these will dissociate and split into ions. So you'll get loads and loads of ions and really none where it's combined. A weak acid like ethanoic acid, when it's dissolved in water, some of it will remain as a compound and some of it will dissociate into ions, so you get partial dissociation when you've got a weak acid. And that's about as far as I want to go with strong and weak acids. So let's have a look at how some of these acids, hydrochloric, sulfuric, ethanoic, all of those, how they will react with metals, metal oxides, metal hydroxides and metal carbonates. And to do that, I'm going to give you 4 general reactions of acids, and if you can remember those 4 general ones, then everything becomes a lot easier, because you can just plug in the names of different acids or the names of different metals or metal compounds, and you can write loads and loads of equations then for lots of different reactions. So let's start with 4 general ones that will help us out. So your first one, acids react with metals to form a salt plus hydrogen gas. Then we've got acid and metal oxide react to make a salt plus water. Acids plus metal hydroxides also make salt plus water. And finally, acids plus metal carbonates make salt and water and carbon dioxide. And now that we've got these 4 general reactions, we can have a look at how to write word equations by plugging in various acids, various metals, metal oxides, hydroxides or carbonates, and then most of the products are given for us. The only problem is we need to figure out how to name the salt in each case, and I'll show you how to do that. Okay, so let's write some word equations. So we'll use the first of our general reactions. Acids and metals make salt and hydrogen. And if your teacher or whoever gives you the name of an acid and the name of a metal, then you need to be able to write that as a word equation. So let's start with hydrochloric acid and zinc. So our acid is hydrochloric acid. Plus metal, which is zinc, makes salt, which we need to be able to name, plus hydrogen. Okay, so the only thing we need to do is figure out what the name of the salt would be based on these two reactants. So I'm going to shift to my next slide and talk about how we name salts, and then we can come back and apply that to this reaction here. So to name a salt, you need to take part of the name of the metal and part of the name of the acid. So I'll talk to you about what a salt is and then show you some examples. So a salt is a compound that's formed when hydrogen ions in an acid are replaced with metal ions. So I'll give you some acids and I'll give you some metal ions and show you how we would name the salt. Okay, a couple of metals that we could use. We use zinc because we started with that one anyway. We could have iron, magnesium, just picking any sort of metals that we could use in this, and I'll do potassium as well. Okay, then we need an acid. So the acids we could have, we'll put hydrochloric acid up here, sulfuric here, nitric here, and we'll do another hydrochloric down here. And then to name the salt, if I go back up here, a salt is formed when the hydrogen is replaced with metal. So in each of these acids, we need to take the hydrogen out and replace that with the metal. So to help us with that, what I'm going to do is I'll give you the formulae of the acids as well so that you can see where the hydrogen is. Okay, so I've added in the formulae here. So when zinc reacts with hydrochloric acid, we're going to replace the hydrogen with the metal itself. Okay, so instead of an H being here, we're going to have some zinc. We'll work on formulae later, but what you'll end up with is zinc chloride. So we can name that salt zinc, which we take from here, and chloride, which we take from here, okay, because we've got rid of the hydrogen. The second one, we've got iron and sulfuric acid. So we're going to get rid of the H and we're going to leave this SO4, and SO4 is called sulfate. So instead of essentially hydrogen sulfate, sulfuric acid, what we'll have instead is iron sulfate. So iron is from the name of the metal, and sulfate, there's a clue in the name of the acid, it's here. Okay. Next one is magnesium. So again, nitric acid is HNO3. You could also think of it as hydrogen nitrate. But we're going to replace the hydrogen and we're going to put the metal in instead, which is magnesium. So instead of hydrogen nitrate, you're actually going to have magnesium nitrate. So that's the name of the salt. So your magnesium comes from the metal, and your nitrate, there's a clue in the name of the acid. And your final one, potassium and hydrochloric acid. Again, we're going to take the name of the metal, potassium, and then there'll be a clue somewhere in the acid, and remember in hydrochloric, it's not this bit of the name, we actually take this bit because we're replacing the hydrogen, we're taking that away and we're using this part. So it would be potassium chloride. And that's how you name a salt. So I'll give you a quick summary of how you name a salt based on which acid you've got. So hydrochloric acid will give you something chloride. Sulfuric acid will give you something sulfate. And nitric acid will give you something nitrate. And all you've got to remember is in these gaps you put the metal that you're reacting with the acid. So hydrochloric acid and zinc would give you zinc chloride. Sulfuric acid and zinc would give you zinc sulfate. Nitric acid and zinc would give you zinc nitrate. So if you want to remember that part, written in purple, that will help you to name all of the salts. Now we can go back to our word equation. We now know how to name salt. We can fill that in and have a look at a few more examples. So our example was hydrochloric acid plus zinc makes some sort of salt plus hydrogen. And now hopefully you know to name that salt. We take the metal, zinc, and we take part of the acid name. So we replace the hydrogen, we take the other part, chloride. So hydrochloric acid always makes a chloride salt. And there's your word equation. So the only difficult part is naming the actual salt. And it's not that difficult when you've had a bit of practice at it. So you can pick any other acid and any other metal and give this one a go again. So let's go for, just change this to a different colour so you can see what we've got. We go for sulfuric acid this time. Plus magnesium. Makes, see if you can name this salt. So you've got sulfuric acid, you've got magnesium. Remember the metal always comes first. Your salt would be called magnesium sulfate. And remember to say plus hydrogen, because every time a metal reacts with acid, it makes hydrogen gas. We know that from our general equation. So let's pick another acid. So we've got nitric acid this time. And we'll pick a metal, so we go with iron. Can we name the salt? Remember the metal comes first. In this case it would be iron nitrate, because it's nitric acid, plus hydrogen. So there we go. That's how we'd write word equations for when an acid reacts with a metal. So now what I'm going to do is I'm going to give you the other three general equations, give you some examples of reactions that you can write equations for. You can have a little go at them and see if you get them right. Okay, so up at the top I've put your four general reactions for acid and metal, metal oxide, metal hydroxide and metal carbonate. And then what I'm going to do is give you some questions or some various reactants and you can write the equation for them. Okay, so here are 8 questions or 8 partial equations. I want you to finish them off, please. So some of them are reacting with metals, some of them are reacting with metal oxides, some of them are reacting with metal hydroxides, and some of them with metal carbonates. So you need to check which of these 4 general equations you're going to use. Remember that they're all going to make a salt and you need to be able to name that salt. So if you're stuck, you can refer to this little bit of information up here. But really what you want to do is use these bits of guidance for maybe the first couple and then see if you can start to write the rest by yourself. So what I suggest is that you pause the video here, have a go at these questions, and then I'll go through the answers in a moment. Okay, so we'll quickly go through the answers to these. Let's get a pen. So sulfuric acid and potassium oxide, well, you're reacting it with an oxide, so we're going to use this equation here. So it's acid plus metal oxide, which we've already got, makes salt, so we need to name the salt. So if we have a look at what we've got, the metal, if you look across here, is potassium, so that comes first, so we'll write that one down, potassium. And the other part comes from the name of the acid, so it's potassium sulfate. That's the name of our salt. And then if we go back to the general reaction, it's plus water, so we need to stick the water on the end as well. Okay, number 2, nitric acid and magnesium. So this time it's not a metal oxide, it's just a metal on its own, so we're going to use this equation at the top. And we know that it makes salt and it makes hydrogen. So first we need to name the salt, so we'll put the metal first, which is magnesium. And then the ending of the salt, if it's nitric acid, will be nitrate. So it's magnesium nitrate plus, if I refer back up here, it's plus hydrogen because it's just a metal on its own this time. So plus hydrogen. And number 3, sulfuric acid plus calcium carbonate. This time we're reacting it with a carbonate. So we're going to use the bottom of our general equations and follow that. So we've got the acid, we've got the metal carbonate. First we need to name a salt, so the metal in number 3 is calcium. and then the ending will come from sulfuric acid, so it'll be calcium sulfate. Plus, if we go back to the equation along the bottom, it's plus water plus carbon dioxide, so we need to write those in as well. Word of warning, it's quite tempting when you get this far to write plus water plus CO2. Make sure that if you're writing word equations, and it does say word equation up here, that you don't then slip into symbols because you get lazy, because that's what I end up doing, but it should all be in words if it's a word equation. So calcium sulfate plus water plus carbon dioxide. Number 4, iron oxide plus hydrochloric acid. Now this one, I have switched the reactants around. So all of these started with the acid, and then the metal or metal compound came next. I've switched these around just to show you that you can have them written in any order. But it's a metal oxide, so we're going to go with the second of our general equations, and we're going to make salt and water. So first we need to name the salt. The metal is iron, and the acid is hydrochloric, so that means that it's iron chloride. Plus, if we go back to the second of our general equations, it says to add water as well. So there we go. Iron oxide plus hydrochloric acid will make iron chloride plus water. Number 5, magnesium hydroxide. So we're doing the third of our general equations, hydroxide, and we're going to make salt and water again. So we need to name a salt. So the metal will be magnesium, and we're going to end it with sulfate. So magnesium, sulfate, plus, and because it's hydroxide, it's going to be plus water, as it says in this equation here. Number 6, nitric acid plus sodium makes, it's the top one, it's this one, so it's going to make salt and hydrogen. So let's name the salt. The metal is sodium, and it's going to be sodium nitrate because you're using nitric acid, plus hydrogen, as it says in the top general equation. Number 7 is hydrochloric acid and copper carbonate. So it's a carbonate, we're going to use this bottom one and make salt and water and carbon dioxide. So let's name the salt. Your metal is copper, and your acid is hydrochloric, so it'll be copper chloride, plus water, plus carbon dioxide. Squeeze that on there. There we go, ish. And the last one, zinc oxide plus sulfuric acid. We're starting with an oxide, so we need to use this equation here. So we're going to make salt and water. To name the salt, we take the metal, zinc, and we add on a clue that's inside the name of the acid, so it'll be zinc sulfate. Zinc sulfate plus, remember it's an oxide, so we're going to go for plus water. And there's the word equations for those. So hopefully you can see that no matter which reactants I give you, if you know those 4 equations and you can remember them for your exam, it becomes really, really easy to write whichever equation you're given. It's just a case of learning how to name a salt. And if you remember these bits, then you'll know how to name a salt as well, and it'll all become very easy. So for the last little part of this, we're going to have a look at writing balanced symbol equations for these reactions, and we'll just use the same reactions that we've already done down here. To help you out with formulae, I'm going to give you the formula of all of the ions that are involved, because if I don't, there's too much to be done in one tutorial. So eventually you'll be able to figure out the formulae of the ions and then write a balanced symbol equation, but for now, let's take that step out just for the moment, and we'll just concentrate on balanced symbol equations. Okay, so we have got all of the equations that we've just done in words up here. Let me put the arrows in, actually, there's no arrows on those. And then the other thing I've given you, just to help out at the moment, is the formulae of any ions that are involved. So we've got negative ions down this side, and we've got positive ions down this side. So we've got all of our metals that are involved here, plus the hydrogen ions, obviously, that come from the acid. Then we've got these that come from acids. So we've got chloride from hydrochloric acid, sulfate from sulfuric acid, and nitrate from nitric acid. And then we've got things like oxide, hydroxide, and I've missed one out, carbonate. There we go. So there's our negative ions as well. So what we're going to do is work through each of these at the top. I'll do a couple for you, and then you can pause the video when you're whenever you think you're ready. Have a go at the rest, and I will continue to work through them. So you can pause this at any point when you think you're ready to have a go. So let's start with number 1. Sulfuric acid is H2SO4. So you need to know the formula of your acids that I gave you at the start of this tutorial. It's got H2SO4 plus potassium oxide. So potassium oxide, potassium is K, and I'm just going to put a charge on it based on what we've got up here. Potassium is a positive ion, so we'll just put a little plus up here just for working out. I'll take that away in a minute. And oxide is O, and according to my list in the corner, oxide is a 2- ion, so we'll put that up there. Now, that tells us, because we've got a 1 plus and 2 minuses, that the formula for potassium oxide is not just KO. We've got to fix it, and we've got to make sure that the number of positive charges and negative charges balances out so that we've got a neutral compound here. So if we've got 1 plus and 2 minuses, think about what else you would need to balance that out. You're going to need another plus, and our positive ion is potassium, so you're going to need another potassium plus. And hopefully you can see then that you've got 2 positives and 2 negatives, so that balances out. So if you need 2 potassiums and 1 oxygen, we can edit this formula to K2O, because we need 2 Ks. And once it's balanced and it's got no charge, we can get rid of our working out charges up here. So potassium oxide is K2O. Makes, well, we've got potassium sulfate, so that's written up here. So we'll do the same thing again. So we've got potassium, which is K, and we've got a charge of plus on there. And we've got sulfate, which is SO4, and the charge, according to our list up here, is 2-. So again, we've got a problem where we've got 1 positive charge but 2 negative charges. So again, we're going to need another potassium. So let's double up on our potassium, put a little 2 here, and then we can remove any of our working out charges. We don't need that, and we don't need that. So it's potassium sulfate, K2SO4, plus, in our equation for number 1, it tells us we need water as well, and everyone knows water is H2O. So there is a chemical symbol equation for what happens when potassium oxide reacts with sulfuric acid. It may not be balanced, because we're not going to balance them just yet. What I'll do is I will work our way through all of these, writing a symbol equation, so that we at least know how to do that, and then we'll go back and balance them at the end. All right, number 2. We've got nitric acid, which is HNO3, plus magnesium, which is just Mg, makes magnesium nitrate. So magnesium is Mg, but the charge on magnesium is 2 plus. And nitrate is NO3, but the charge on nitrate is 1-. So we need to fix this because we've got 2 pluses and 1-. So to get those to balance, we need another negative ion. So the negative ion is this nitrate ion here. We need 2 of those. Now, because nitrate is made out of more than 1 element, so the whole ion is made out of more than 1 element, what we can do here is we can bracket it and say the whole nitrate ion, we need that twice. And then that will balance out our charges, and we can take away any of our working out here. So if you've got sulfate, nitrate, hydroxide or carbonate, these are our ions that are made out of more than 1 element combined together. If you need more than 1 of those ions, you need to put brackets around it and then say how many you need at the end. So that's how you do that one. Magnesium nitrate. Plus, for number 2, it was plus hydrogen, and hydrogen is diatomic. It comes in 2s, so it's H2. Okay, number 3. Don't forget, at any point you can stop, pause this video and try and do the rest yourself, but I'll carry on. So we've got sulfuric acid, which is H2SO4, plus calcium carbonate. So we've got calcium, which is Ca, and the charge on calcium is 2+. And carbonate, which is CO3, and the charge on carbonate is 2-. Now, because we've got equal numbers of positive and negative charges, that's fine as it is. We don't need to have any more ions, so we can get rid of that working out. And the formula for calcium carbonate is just CaCO3. Okay, oh, wrong colour. Makes calcium sulfate, so we've got calcium, which we know, again, is a 2+ ion, and sulfate, which is an SO4 2- ion. Again, we have got 2 positives and 2 negatives. They cancel each other out, so we can get rid of our working, and calcium sulfate is just CaSO4 plus water, which we know is H2O, plus carbon dioxide, which we know is CO2. Okay, so that's number 3. Number 4 is iron oxide. So we've got iron, and the charge on iron is 2+. By the way, iron is a transition metal, so it can have other charges. You can have iron 2+, or you can have iron 3+, mainly. But in this case, I've said that we're going to use iron 2+, so we'll stick with that. And it was iron oxide, so we need O, and O is 2-. So again, we've got a case where our charge is already balanced, so we can get rid of our working out. And iron oxide is just FeO in this case, plus hydrochloric acid, which is HCl, makes iron chloride. So we've got Fe, which we know is a 2+ ion, and Cl, which we know is a 1- ion. Now our charges don't balance, so we need to work with this. Which ion do we need more of to get these charges to balance? We've got 2 pluses, we will need 2 minuses, so our chloride needs to double up. So chloride is FeCl2. There we go. Now we can get rid of our working out. Rid of those charges because it's now neutral. Iron chloride plus water, which is H2O. There we go. And number 5, we've got magnesium hydroxide. So we've got magnesium, and we know hydroxide is OH because we've got it over here. Now we need to put the charges on to see if it's the correct formula. Magnesium is 2+, hydroxide is only 1-. So we need to double up on negative ions, and in this case the negative ion is made out of 2 elements joined together. So to double up the whole hydroxide, I'll stick brackets around it. There we go. And a little 2 to say we've got 2 lots of that. Let's get rid of working out. There we go, and that's magnesium hydroxide. Mg, OH in brackets with a 2. And what are we reacting it with? Magnesium hydroxide plus sulfuric acid, which is H2SO4, makes magnesium sulfate. So we'll do some working out again. So we've got magnesium, which is a 2+ ion, and sulfate, which is a 2- ion. So both of these charges balance each other out, so we don't need to do any changes to the formula. So we can get rid of those. Magnesium sulfate is MgSO4 plus water, H2O. Number 6, nitric acid, HNO3 plus sodium, which is just Na, makes sodium nitrate. So Na, sodium, is a 2+ ion, is a 1+ ion, and nitrate, NO3, is a 1- ion. So these 2 charges cancel each other out, so we don't need to do any changes to that, so we can get rid of these. Get rid of our working out. NaNO3 is sodium nitrate, plus hydrogen, H2. Okay, so there's our first 6. Make some more space and we'll do the last 2. Alright, number 7 was hydrochloric acid, HCl, plus copper carbonate, Cu. And the charges on that, Copper is 2+ in this case. It's another one that can have multiple different charges, but I've said 2+ for this one. And carbonate, CO3, and the charge is 2-. So these already cancel each other out, so we can get rid of our working. Oops, start again. Get rid of our working, and it's CuCO3, it's copper carbonate. Makes copper chloride, so Cu we know is a 2+ ion, and Cl, chloride, is a 1- ion. This doesn't quite work out. We're going to need 2 chlorides to balance out our charges, so we'll put a little 2 here, and now it balances so we can get rid of our working. Okay, plus water, which is H2O, plus carbon dioxide, which is CO2. And finally, number 8, zinc oxide. So we've got zinc, and zinc is a 2+ ion. And then we've got oxide, and oxide is a 2- ion. So these charges already cancel each other out. We don't need to worry about them. So we can get rid of our working out, and it's just ZNO. I'm going to write that a little bit closer together so that you can see it's all one formula. Zinc oxide plus sulfuric acid is H2SO4. Makes zinc sulfate, so we've got zinc, which is a 2+ ion, and sulfate, which is a 2- ion. So they already cancel out. That's the correct formula, so we can get rid of the working out. ZnSO4 plus water, which is H2O. There we go. Okay, so I went through that fairly quickly. Hopefully you went part way and then started to try some of them on your own. It's just a case of inputting what you've got over here into your word equation, and the only difficult part is making your charges balance between positive and negative ions. So figuring out, for example, copper chloride is not just CuCl, it's actually CuCl2. If you can do that, then you're fine for writing symbol equations. What we need to do is check that these symbol equations are balanced. So let's have a little look and see whether we've got any that are not balanced. Okay, so number 1, number 3 and number 8 are already balanced, so we'll take a look at the rest of them and work on balancing those next. Okay, so balancing the equations then, let's have a look at number 2. So again, what we'll do with this is I will work my way through and I'll balance all of them. But when you feel that you're ready to try and balance some of them yourself, or if you feel like you're ready now, pause the video at an appropriate point, have a go at it, and then come back to see if you were right. So I use a bubble method to figure out whether or not something's balanced, and then to work on balancing it. So what I do is I take each of the reactants in each of the products and I list the elements that are in them. So HNO3, I've got an H, an N, and 3 oxygens, and I put a bubble or a box around it. That's to protect it and to stop me from changing the formula into something that it shouldn't be. Magnesium is just an Mg atom on its own. And then I get to the arrow, so I'm going to put a line down to show that we're now turning into products. My next chemical that I've got is Mg, NOOO, but the nitrate is doubled up, so we've got another NOOO, and we'll put a box around that to protect its formula. And the hydrogen is 2 H's, like that. Okay, I take an element in turn and I try and find out whether or not it's the same on both sides. So I'm going to start with hydrogen. On the whole left-hand side, I've got 1 hydrogen, and on the whole right-hand side, I've got 2. So where do I need more hydrogens, left or right? I need more hydrogens on the left. So I choose a box that's got hydrogen in it, and I draw it again. On the left, this is my only box that's got hydrogen in it. So I'm going to double it up. So I'm going to copy that box and stick it there. So I'm starting with 2 lots of nitric acid now, and that helps because I've now got 2 hydrogens going into my reaction and 2 hydrogens coming out the other side. Okay, so let's go for nitrogen. I've now got 2 nitrogen going in, and I've got 2 nitrogen coming out, so that's balanced as well. Oxygen, I've got 6 oxygens going in, and I've got 6 oxygens coming out, so that's balanced as well. And magnesium, I've got 1 going in and I've got 1 coming out, so that's balanced. So all it took to balance that equation was to double up my nitric acid. So to balance it, all you need to do is stick a big 2 in front of nitric acid, because I've got 2 of those boxes. All of the rest, I've only got 1 box each, so I don't need to edit the equation. So now I can get rid of all of my working out, and that is the balanced symbol equation for question 2. Okay, so number 3 is already balanced, so let's have a look at number 4. So here's our equation: iron oxide plus hydrochloric acid, mix iron chloride plus water, and I'm going to do the bubble method again. So underneath, I'm going to say which elements I've got and how many. So here I've got 1 iron and 1 oxygen, box it. Here I've got 1 hydrogen and 1 chlorine, so I'll box that. Then I've got an arrow, so I'll make it clear that I'm going on to the products. Here I've got an iron and I've got 2 chlorines, box that. And here I've got 2 hydrogens and 1 oxygen, and I'll box that. Taking one element at a time, iron first. Iron going in, on the whole left-hand side I've got 1 and it's here, and on the whole right-hand side I've got 1. So iron is balanced. Oxygen, I've got 1 going in, and I've got 1 coming out, so that's balanced. Hydrogen, I've got 1 going in, which is here, but I've got 2 coming out. So the hydrogen is not balanced. So to balance it, I need to decide which side do I need more hydrogen on. I've got 1 here and I've got 2 here. So I need to put more hydrogen on this side to get it to balance out. And which box on the left has hydrogen in it? Well, it's this box here, so I'm going to draw that box again. So let's repeat that box and put that there. Now you can see that we've got 2 hydrogens going in and 2 hydrogens coming out, so my hydrogens are now balanced. And chlorine, I have got 2 going in now that I've edited it, and I've got 2 coming out, so that's fine as well. It's always a good idea to go back and check all of your elements again. 1 iron, 1 iron, 1 oxygen, 1 oxygen, 2 hydrogens, 2 hydrogens, and 2 chlorines and 2 chlorines, just in case you've changed something along the way. Okay, so to complete our balanced symbol equation, we go through each species within the reaction and decide how many times we've had to draw that box. So how many lots of iron oxide have we got? Just the 1, so we leave it alone. Hydrochloric acid, we've got 2 lots of that, so we need a big 2. Iron chloride, we've only got 1, and water, we've only got 1. So that is the final equation. So FeO plus 2HCl makes FeCl2 plus H2O. Okay, so let's have a look at question number 5. See if we can balance that. Remember, if you think you can balance them, pause the video, have a go at them, and then check it out by returning to the video. So the equation for number 5. There we go. So we're going to write underneath what each species is made of. So this has got 1 magnesium. It's got an O and an H, but the OH has been doubled up, so it looks something like that. H2SO4, it's got 2 H's, it's got an S, and it's got 4 O's. So it looks like that. Then we come to an arrow, so I'm going to make that clear by drawing a line. And then magnesium sulfate is made out of magnesium, sulfur, and 4 oxygens. Water is made of hydrogen, hydrogen, and oxygen. Okay, now we're going to take an element at a time and decide what's going on. So have we got the same on both sides for magnesium? On the whole left-hand side, I've got 1 magnesium atom, and on the whole right-hand side, I've got 1 magnesium atom, so that's fine. On the whole left-hand side, for oxygen, be very careful because it appears in 2 different places now. So oxygen, I've got 1, 2, 3, 4, 5, 6 on the left, and on the whole right-hand side, I've got 1, 2, 3, 4, 5 on the right. So oxygen is a bit of a problem. And we need to make sure that there's more oxygen being put on the right-hand side, because there's only 5 at the moment here, but there's 6 here. So one way we can do that is if we doubled up this box, we'd actually end up with tons of oxygen on this side and it would mess everything up. But if we double up this box, let's have a look. So 1 more water. We've now got 1, 2, 3, 4, 5, 6 oxygens on the right to match my 6 oxygens on the left. So that's looking good so far. Hydrogen on the left, I've got 1, 2, 3, 4. And on the right, I've got 1, 2, 3, 4. So that's looking good. Sulfur, I've got 1 on the left and I've got 1 on the right. And I think that's looking pretty good. So you can check through each element again just to make sure. And then you need to edit your equation. So how many times have we drawn the first box? Just once, so we leave it. Second one is just once, so we leave it. Magnesium sulfate we've only drawn once, so we can leave that. But water we have drawn twice, so we have to edit our equation and stick that in front of H2O. And there is your equation for number 5. Okay, number 6 also needs balancing, so let's write the equation for that. Okay, and underneath we're going to write what's in each of these species. I'm going to make sure we draw a line when we get to the arrow. Okay, put a box around everything to make sure that we're protecting it. Okay, so we have protected all of our formula, put boxes around them. Now we just need to take each element. So hydrogens, we've got 1 and 2. We need to make sure that we've got more hydrogens on the left-hand side so that they balance. So we pick a box on the left, one that's got hydrogen in it, which is this one, and we draw it again. So now we've got 2 hydrogens going in and 2 coming out. So then we have a look at nitrogen. So we've got 2 nitrogens going in and we've got 1 coming out. So we need more nitrogen on the right-hand side. So we pick a box on the right that's got nitrogen in it, which is going to be your sodium nitrate, and we draw that box again. So now we've got 2 nitrogens going in on the left and 2 coming out on the right. Okay, so oxygen, we've got 6 on the left and we've got 6 on the right, so that's balanced, that's absolutely fine. Sodium, we've got 1 on the left, but we've actually now got 2 on the right, so we need to put more sodium on the left-hand side. So we pick a box on the left-hand side that's got sodium in it, so it's obviously just your sodium on its own, and draw that again. And now our sodiums, we've got 2 on the left and we've got 2 on the right. So you can check that all of those still balanced. We can go through each of the elements again and just double check them. But now we need to make sure that we're putting in the big numbers. So 2 lots of nitric acid, 2 lots of sodium, and 2 lots of sodium nitrate, and we've left the hydrogen on its own, so we don't need to worry about that. So that's your equation for number 6. So finally, we've just got number 7, so let's write the equation for that. And let's do our bubble method. So we've got an H and a Cl, put a box around it. A copper, a carbon, and 3 oxygens, put a box around it. We put a line down when we get to the reactants, write down what we've got in each of these and put a box around each of them so that we don't change the formulae. And then we can check each element in turn. So hydrogens, we've got 1 going in on the left and we've got 2 coming out on the right. So we need to fix that by putting some more hydrogen on the left-hand side. So that's this box, we'll draw it again. So now we've got 2 H's going in and 2 coming out. We can look at chlorine, 2 going in and 2 coming out, so that's fine. Copper, we've got 1 going in and 1 coming out, so that's fine. Carbon, we've got 1 going in and we've got 1 coming out, but you need to be careful with carbon just because you've got all of these different symbols that have got capital C's in. So you've got chlorine with a C, you've got copper with a C, and you've got carbon with a C. So just make sure you're looking for the right symbol, which is just a capital C on its own. So 1 carbon in, 1 carbon out. Oxygen, we've got 3 oxygens going in and we've got 3 oxygens coming out. And now you can check everything again, but just by doubling up that hydrochloric acid, you've balanced the entire equation. So we need 2 in front of the HCl, and we leave everything else as it is. And that's your balanced symbol equation for number 7. So there's a lot been covered in this tutorial. We have gone from the 4 general equations for reactions of acids with metals, metal oxides, metal hydroxides, and metal carbonates. We've then looked at how we can substitute chemicals into those equations to write word equations. We've looked at how we name the salt in each case. So hydrochloric acid makes a chloride salt, sulfuric acid makes a sulfate salt, and nitric acid makes a nitrate salt. We've then looked at how we can turn those into symbol equations, making sure that the formulae are correct by balancing out the ions, the charges on the ions. And finally, we have practiced some balancing equations right at the end to make sure that our symbol equations are completely correct. So in the amount of time that we've actually spent on this, we've covered an awful lot. But I hope that it's been useful to you anyway to practice all of those different skills in one session.